Hello guys, my name is Madam Siame and I want us to explore a grade 11 topic which has become a bit challenging for some folks. So let's just explore some ideas here and there. This time I'm talking about kinetic theory and gas laws, the relation. So for us to understand the relation between gas laws and kinetic theory, we need to understand three factors, which is temperature, volume, and pressure. So what is the effect of these three things on gas? So to best explain the effects, we need to know three laws which are vital and key. So these laws are what are going to help you tackle questions when it comes to these three laws. Because a lot of students mix up and then try to answer questions and relate them to kinetic theory, Brownian motion, which is not the case because this one now is totally different, though they are related because they are all under thermophysics. So let's talk about the first one, which is Boyle's law. Boyle's law is just simply the relation between volume and pressure. And then you ask, where is temperature? Temperature is constant in this instance. It's not changing. So we assume temperature is constant. What will happen to volume? What will happen to pressure? So what will happen to volume is it will either increase or decrease depending on what is happening to pressure of that substance. So if I reduce the pressure, I increase the volume. If I increase the pressure, I increase the volume. I reduce the volume rather. Forgive me for that. A real life application of Boyle's law. We go to tires. Your bicycle or vehicle, since you don't have vehicles, you're still young. Your bicycle, usually once in a while, you have to pump in air. So when you pump in that air, you are adding more pressure inside the tires. Now, what is happening to volume? Let's go back to the definition of volume. We said volume is the space in an object. So meaning if I pump in air in the tires, in my bicycle tires, the pressure increases, yes. But the volume or the space reduces. Why? Because I've pumped in more gas particles. So particles are more and the spaces inside the bicycle are few. Hence, Boyle's law applies. I have increased pressure. I have reduced volume in the tires. It is with this reason that the pressure will act on the walls of the bicycle and hence help you to move smoothly and effectively on the road because the tires are now firm. Let's go to another law, which is Charles' law. So here, Charles' law, pressure now is constant. Pressure is constant. Volume and temperature are what at play here. It's simple. When I increase volume, I increase the temperature. Or if I increase the temperature of a substance, I also increase the volume. How is this working? Let's go back again to kinetic theory of matter. Remember when you heat a substance, the volume between the volume inside the particles increases, meaning the spaces increases, and hence making it, if a substance was liquid will probably become gas. Why? Because that substance has become less dense. It has become less heavy. Why is it less heavy? Because the volume has increased. What has increased the volume? The temperature itself has increased the volume. A real life application is a hot air balloon. A hot air balloon has gas which is dense and hence it is there seated. So the gas inside is more heavy than the gas outside, which is making the hot air balloon to set where it is. But let's heat it up. We see fires in hot air balloons especially in movies. I haven't been in an hot air balloon before, but you will see a fire. What is the whole purpose of that fire? Is to increase the temperature so as to heat the gas. So hence the gas will become less dense because the volume in the gas, the spaces have increased, and hence making the gas inside the hot air balloon become less dense than the one outside. Now because it's less dense, this will push the hot air balloon up. Let's go to the last one, which is pressure law or Gay-Lussac's law. So sometimes they might use Gay-Lussac's law or pressure law, or they might give you a scenario to describe what kind of law is working here. You can either put Gay-Lussac's or pressure law. They are all correct. So what is pressure law? Here and now, volume is constant. So if I increase the pressure, if I increase the temperature, I also increase the pressure. As simple as that. The perfect example I would give in our day-to-day lives is a pressure cooker. The more I increase the temperature, the more the pressure inside, hence making the food cook more faster because there's a lot of pressure inside. Of course, the volume is kept constant because the pressure cooker is tightly sealed and no air is going in at all. So there the volume is constant. So as I increase the temperature, even the pressure in that pressure cooker increases, hence making the food cook more faster. I'll be back again exploring more ideas on thermophysics because I know a lot of pupils leave questions on thermophysics which can earn you marks in the exam. So till next time, thank you for listening. Forgive me for my lighting, it's bad, but I'll work on it. It's goodbye. My name is Madam Siame.